This dinosaur started as a completely flat sheet of MDF. It is made from 29 separate pieces, it does not require any glue, and by the end of this video, I will show you how you could turn a simple laser cut project like this into a complete product that you can actually sell. But before we start, welcome to day 1 of my new challenge. I am going to make 100 new laser products in 100 days. Every day, I will choose a different product, cut it with my laser, assemble it, and show you the complete process from a digital file to a finished physical product. Some projects will be simple, others will be more complicated. I will work with MDF, plywood, acrylic, and other materials that can be processed with a laser machine. I will also share the small details that make the difference between something that was simply cut with a laser and something that actually looks and feels like a real product. That includes choosing the right material, adjusting the design, testing the joints, reducing waste, assembling the product, packaging it, and thinking about the type of customer who might want to buy it. The reason I decided to start this challenge is simple. A lot of people buy a laser machine, make a few signs, keychains, or decorations, and then run out of ideas. They have the machine, they know how to cut, but they are not sure what products they should actually make. I want to show that a laser is much more than a machine for cutting shapes out of wood. It can be a tool for creating hundreds of completely different products. And you do not necessarily need a huge workshop or extremely expensive materials to start. Sometimes all you need is a good file, a small amount of material, and a clear idea of how the finished product could be presented to a customer. For day 1, I chose this 3D dinosaur puzzle. It is made from 29 individual pieces that fit together to create one large dinosaur skeleton. For this project, I am using 3mm MDF. In my opinion, 3mm is the ideal material thickness for this particular design. It is thin enough to cut relatively quickly, but it is still strong enough for the finished dinosaur to feel solid and stable. The final dinosaur is also large enough to look impressive without becoming too big or difficult to package. Before cutting the complete design, there is one very important thing that needs to be adjusted. The slots in the design need to match the actual thickness of the material. This MDF is sold as 3mm MDF, but that does not always mean that its exact thickness is precisely 3mm. Depending on the manufacturer and the individual sheet, the real thickness can be slightly different. That small difference might not sound important, but with a product like this, even a difference of a few tenths of a millimeter can completely change how the pieces fit together. If the slots are too wide, the pieces will feel loose. The dinosaur might still stand, but the joints could move, and some of the pieces might fall out. You would probably need to use glue to keep everything together. If the slots are too narrow, assembling the product becomes difficult, and applying too much pressure could damage or break the MDF. For this dinosaur, I reduced the entire design slightly so that the slots are approximately 2.8mm wide. Even though I am using material that is nominally 3mm thick, those slightly narrower slots create a tight friction fit. That means the pieces hold each other firmly once they are connected. There is no glue, no screws, and no additional hardware. That difference of only 0.2mm is almost invisible, but it makes a major difference in the finished product. This is why I always recommend making a small test before cutting the complete project. Instead of immediately cutting all 29 pieces, you can cut 2 small test pieces with the same slot dimensions. Connect them and check the fit. If they are too loose, reduce the slot width slightly. If they require too much force, make the slot a little wider. A small test like that only uses a tiny amount of material, and it can prevent you from wasting an entire sheet. While the laser is cutting, this is also a good time to think about the layout of the pieces. When you are making only one product, a small amount of unused material might not seem important. But if you decide to produce 10, 50, or 100 of these kits, the way you arrange the pieces can have a significant effect on your costs. The closer you can place the pieces without creating problems during cutting, the more products you can make from one sheet. Better material utilization means less waste and a lower production cost for every dinosaur. The correct cutting settings are also important. You want enough power to cut completely through the MDF, but you do not want to use more power than necessary. Too much power or an unnecessarily slow cutting speed can create darker, dirtier edges. Using too little power can leave sections that have not been completely cut. There is no single setting that will work perfectly for every laser machine. The correct settings depend on the power of your machine, the actual density of the MDF, the focus, the condition of your lens and mirrors, and the amount of air assistance you are using. That is why testing your own material is always more useful than simply copying somebody else's settings. The cutting is now complete, so I can start removing the pieces. This is one of the most satisfying parts of the process, but it is also an important quality control step. Before assembling or packaging the dinosaur, I need to make sure that every piece has been cut correctly and that none of the slots are blocked. Because this puzzle contains 29 separate pieces, one missing piece would make it impossible for the customer to complete the dinosaur. If I were producing this product in larger quantities, I would create a simple checklist or a reference image showing all 29 pieces. Before closing each package, I could quickly compare the contents with the reference and confirm that the complete set is there. That may seem like a small detail, but quality control becomes extremely important once you start selling physical products. The customer does not know how much work happened inside your workshop. They only see the product that arrives in the box. Now we can start assembling the dinosaur. The order of assembly matters because some pieces become harder to insert once the main body has been completed. I am starting with the central structure because this creates the foundation for the rest of the dinosaur. From there, I can gradually add the body sections, the ribs, the legs, and the smaller pieces that create the final shape. And this is where you can really see the effect of reducing the slots to 2.8 millimeters. The pieces require a little pressure, but they still connect without being forced. Once they are in position, they stay there. The goal is not to make the joints as tight as possible. The goal is to make them tight enough to hold the dinosaur together while still allowing the customer to enjoy the assembly process. A customer should not need a hammer, excessive force, or glue to finish the puzzle. The product should feel secure, but it should also be enjoyable to build. If you are producing this as a children's activity, the recommended age, the size of the pieces, the finish, and the relevant product safety requirements in your market should also be considered before selling it. You can also make this dinosaur from thicker material. For example, you might want to use 4mm plywood or MDF to create a stronger or more premium version. In that case, every slot needs to match the thickness of the new material. One option is to open the design and manually change the width of every slot. That gives you more control, and it allows you to keep the overall dimensions of the dinosaur almost the same. But there is also an easier option. You can proportionally scale the entire design until the slots match the thickness of your material. For example, if the original slots were designed for approximately 3mm material, and you increased the complete design for 4mm material, all of the slots would increase at the same ratio. The important thing to understand is that the complete dinosaur would also become significantly larger. That could actually be useful if you wanted to create a larger display model, a shop decoration, or a more expensive premium version. But for a standard puzzle kit that is easy to cut, package, store, and ship, I think 3mm MDF is the best option. And here is the completed dinosaur. We started with a flat sheet of MDF and ended with a large 3D model made from 29 interlocking pieces. It is stable, it is strong enough to handle normally, and the complete structure holds together without a single drop of glue. But this project does not have to remain something you make only for yourself. You can turn it into a complete product and offer it to your own customers. Instead of assembling the dinosaur before selling it, you can sell it as a DIY puzzle kit. After cutting the 29 pieces, place them inside a clear plastic bag or another simple protective package. The bag keeps the pieces together and prevents the smaller elements from becoming lost during storage or shipping. The next thing you need is an assembly guide. It does not have to be complicated. While assembling the first dinosaur, take a photograph at every important stage. Arrange those photographs in the correct order and add a short explanation under each one. You could fit the complete guide onto 1 or 2 printed sheets. The most important thing is that the customer can clearly see which piece should be used first and where every following piece needs to go. You can then place the bag of laser cut pieces and the printed instructions inside a cardboard box. Add your logo, the name of the product, a photograph of the completed dinosaur, and some basic information about what is included. At that point, you are no longer selling 29 pieces of MDF. You are selling a complete 3D dinosaur puzzle kit. The customer opens the box, follows the instructions, builds the dinosaur, and gets the satisfaction of creating the final product themselves. That experience is a major part of the value. There are several different groups of customers you could target with a product like this. Parents could buy it as a hands-on activity for their children. It could be marketed as a birthday or holiday gift. Grandparents and other family members could buy it for children who are interested in dinosaurs, building, or creative projects. You could also offer it to schools, workshops, activity centers, gift shops, museum shops, and educational toy stores. Another option would be to sell the dinosaur as a paint-your-own kit. You could include the natural MDF pieces, a small brush, and a selection of suitable paints. The customer would first assemble the dinosaur and then decorate it. That turns one project into 2 different activities and allows you to offer a more expensive version of the same basic product. You could also create a collection. Instead of offering only one dinosaur, you could create several different species. A customer who enjoys building the first one might return to buy the next model. You could sell them individually or create a complete dinosaur bundle. This is how one simple laser file can become the starting point for an entire product line. You are not just selling the material. You are selling the design, the packaging, the activity, and the final experience. So that is day 1 of my 100 days, 100 laser products challenge. The link to this dinosaur file will be available in the video description, and for day 2, I'm going to make a very interesting box. It may look simple at first, but its design and the way it is assembled could make it a very strong product to add to a laser business. I will show you how to cut it, put it together, and present it as another finished product that is ready to sell. I will see you in day 2.